Good morning. Today we are going to do the Fourier series, but not for the whole period. We are going to have half range. Okay. So before I start having Fourier series for the half range, I'm just reminding you when we have Fourier series for even function. So in the even function, Bn will be 0, right? Because as you know, we have Fourier series an and a naught related to the cosine, bn related to the sine. So once we have even function, and we know sine is odd function, so this sine part will disappear in the Fourier series. So from the beginning, if you know your function is even, no need to waste your time by finding this integration, right? Straightforward, write bn equal to 0 when your function is even. Okay? Because your period from minus L to L, so your period is 2L. So you substitute in the formula of A naught by 2L. So start from minus L to 2L. Because this function is even, so the definite integral property saying this one you can start from 0 to L and you multiply by 2 by finding the half of the integration and multiply it by 2. Because this is the area under the curve. If your function is even, so you have two equal half. So it is better to go from 0 to L and multiply by 2. Also, an will be the same. Again, if you have even function, what does it mean even function? It means it is symmetric with respect to y-axis. Or if you replace t by minus t, you will have the same function. Okay, so if you have even function, Bn will be 0, and you need only to find a naught and an. What about if your function f of t is odd? What does it mean f of t is odd? It means when you replace t by minus t, I will have the same function multiplied by minus, right? Or the graph of this function will be symmetric with respect to the origin. Okay, so I know my function is odd, so I will not have any even part. The even part related to the cosine, because cosine is even. So this cosine will disappear in the Fourier series of the odd function. So an and a naught will be 0. You find only bn. And your Fourier series for the odd function will have only bn multiplied by sine. Okay. Why I'm revising this one? I'm revising this one because it is 90% of our lecture today. Let's go for this exercise. Find Fourier series for the function for which the graph is given by. Again, I have to check my function is even or odd. When I look at the right half to the origin, it is up here. The left half is down here. So you don't have two similar two halves, right? But this one is reflected with respect to the origin. So this function, odd or even? Can anybody answer me?
Odd.
Thank you very much. Thank you very much. The second one, so because if it is odd, which coefficient you are going to have? Can anybody answer me?
Bn.
Only Bn. Thank you very much. Let's go for the second one. This function, even or odd? Yes, I can replace t by minus t, even if I don't have the graph. If I replace t by minus t, cosine is even, right? So this function will be even or odd? Even. Thank you very much. Even. So what is the coefficient you are going to find?
An and Bn.
No, sorry. An only.
Yeah.
An and a naught, of course.
Yeah.
Bn is 0 because the function is even, right? Why he's writing this one? He's writing this one. What does it mean? F of t equal to f of t plus 2. it means my function is periodic and the period is 2. So the period t is equal to 2, or the period 2L equal to 2. Okay, so in the first one, I know the function is odd. So I'm going to find only the coefficient Bn in the Fourier series. Now, I don't know the graph of this one, so I can replace t by minus t. So I know cosine is even, so the whole thing is even. So this function Bn in the Fourier series for this one is 0. So I find only a0 and an. What is the point of writing f of t equal to f of t plus 2? It means this function is periodic and the period is equal to 2. Let's go to find the Fourier series. Here, someone wasted his time, right? And by the end, he find a0 and an equal to 0, right? Why? Because this function is odd, right? Why it is odd? Because in the negative half, it is minus 3. In the positive half, it is 3. So this is odd function. Because it is odd function, straightforward, a0 equal to 0 and an equal to 0. So you need to find Fourier series for this one only by finding the coefficient Bn, right? To find the coefficient Bn, you have to know the period of this function. You have the period, you start from minus pi, you end by pi. So the period is 2 pi. And also he will write for you f of t equal to f of t plus 2 pi, right? Or if he's defining the function like this one, so you know the distance between the start point and the end point is the period of your function. Now, how to find Bn? Bn 1 over 2 over the period. So 2 over the period, and the period is 2 pi. So 2 over 2 pi will be 1 over pi. Integration from minus pi to pi for your function I. Bn, so I have to multiply by sine 2n by t over 2n by t over the period. The period is 2 pi, so you cancel 2 pi with 2 pi, so you end up with sine nt. Now, can I integrate from minus pi to pi straightforward? No, because your function is stepwise function. It has definition from minus pi to 0 by minus 3, and have another definition from 0 to pi by 3. So I will integrate from minus pi to 0 and from 0 to pi. From minus pi to 0, I know my function is minus 3 multiplied by sine, because this is the definition of the coefficient Bn, plus integrating from 0 to pi for the definition of my function at this interval from 0 to pi, which is 3. So this is my function. From the definition of Bn, I have to multiply by this one, sine nt dt. This is an easy integration because you take this minus 3 outside, okay, and you integrate only sine. The integration of the sine is minus cosine. This is why the negative sign here is disappeared. You have cosine minus cosine nt over the derivative of the angle nt. You differentiate with respect to what? Where you independent variable t. So the integration, the derivative of the angle will be n. And you put the boundary of your integration, the lower bound and the upper bound. Next, this is the same integration at this one, but this time you don't have negative, you have positive. This is why you have the integration of sine is minus cosine nt over n. This n is a derivative of the angle. And the lower bound is 0, the upper bound is bar. Now, I substitute by the upper value, 0, and then minus, substituting by the lower bound. Because you have negative here, multiplied by positive here, you have negative. And you substitute by pi, so cosine n pi, substituting by 0, cosine 0. I know cosine 0 is 1, right? So you have 1 from here, and you have 1 from here. The total will be 2. You have minus cosine n pi here, and minus cosine n pi. What is the minus here? It doesn't matter because cosine my cosine is what? My cosine is even function. So even if you have negative angle, it doesn't matter. It is negative or positive, you have the same value, right? So this negative disappear because the cosine is even function. Okay. Now this one minus this one, you have minus cosine 2 cosine n pi. And you take 2 as a common factor. 2 multiplied by 3, it will be 6 over by n. And this is will be, if n is even, this one will be 0 because cosine 2 pi will be 1. 1 minus 1 will be what? 0. So when n is even, the cosine will be 1. And you have here 1 minus 1. So when n is even, the total value will be 0. But when n is odd, you have cosine pi, cosine 2 pi, cosine, which is equal to 1 or 2 or 3. So you have 1 minus 1. So you have 1 minus minus 1, you have 2. 2 times 6 will be 12. Again, when n is even, you have cosine 2 pi, cosine 4 pi, cosine 6 pi. Cosine 2 pi is 1. Cosine 4 pi is also 1. So 1 minus 1 will be 0. So n even, make this value 0. 0 multiplied by this one will be 0. But when n is odd, this one will be minus 1 because you have cosine pi, cosine 3 pi, cosine 5 pi. 1 minus minus 1 will be 2. 2 times 6 will be 12. So this is a coefficient Bn. Now, once you find Bn, you just write it down here, right? So my Bn is 12 over this one. Okay. This is my Fourier series for my function 3n minus 3. Okay. So I can write my function as a power series like this one. Okay. So you have Bn, you substitute by Bn, and you have this sine n. How I get this one? Yes, because you have from Bn, you have this one, multiply, because n is odd. How to write n is odd? You can write it down as 2n minus 1, because as I said before, when n is even, you have 0. So no need to add or to sum n is even. So you go for n is odd. How to express n is odd? By typing 2n minus 1. If you put n equal to 1, you have 2 minus 1 is 1. N equal to 2, you have 4 minus 1, which is 3. So you will get only the odd values, right? So this is your power Fourier series for the function f of t from minus 3 to 3. This is a half negative. This is a half positive. Okay, if you would like to graph this Fourier series, okay, as a function, this big sum, you make it a plus, 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 and take 4 or 5 terms or 6 terms, so you will have a power series. Graphing this power series, it will be exactly close to your function here, right? So instead of having minus 3 and positive 3, you will have the smooth stuff to at 3 and also at minus 3. So the main point of it changing the sharp wave into smooth one. This is your Fourier series, okay, for the function from 0 to minus pi, it will be minus 3, and from 0 to pi, it will be 3. But it will be sharp like this one. If you replace the function by its Fourier series, it will be smooth like this one. Okay. Let's go for the second one in the exercise, if you remember. This is the second one, right? We would like to have the Fourier series for this one. As we said, this is even or odd. We said even, right? Because it is even, no need to have Bn, because Bn will be 0. Okay, so we know our function is even, so Bn will be 0. So I will have only A naught. What is that expression for A naught? 1 or 2 over T, which is, or you can write it 1 over L from minus L to L for f of t dt. My boundary from minus 1 to 1, f of t dt. I cannot integrate from minus 1 to 1 because my function is 0 from minus 1 to minus half, and my function from minus half to half is cosine 3 by t, and my function from half to 1 is 0. So you only need to have this definite integral. What is the integration of cosine? It is sine, the same angle, dividing by the derivative of this angle with respect to t, my independent variable. Once you integrate, you substitute by the lower bound and the upper bound. Okay? So you will have a naught like this. To find an, you have the formula for an like this one. Okay? This is your function. Again, you are not going to integrate from minus 1 to positive 1 because your function is only defined at this interval from minus half to positive half. Okay, so this is your function at this interval. Okay, and multiplied by cosine n by t. This is from the formula of an. This is the integration. How to integrate this one? As I said, you will start to integrate this one. It is easy to have it one by one using your calculator. Okay, so like this one, you can find a naught and divide it by 2. As I said before, some box using this formula, instead of writing a naught, you write it a naught over 2. This is why here he doesn't have 2 up here, right? Okay. Now I find a naught, I substitute it. I find a1 by the calculator and substitute it. I find a2, I substitute it. And instead of having this integration, okay, in one go. But this one you can integrate using the cosine of the sum of two angle, right? And you can manage, of course. But if you cannot do the integration in one go, it is easy for you to go one by one. So you replace n equal to 1 here. So this one will be cosine 3 by t times cosine by t. Can you find the integration by your calculator from minus half to half? Cosine 3 by t, cosine, both n equal to t, to 1, so cosine by t. How much it will be? If you have a calculator, please do it. Supposed to be 6 over 5 bar. So this is a A1, right? So A1 supposed to be 6 over 5 bar. If you replace n by 2, you will have A2, and A2 supposed to be 1 over 2. Okay, so again, if you cannot do this integration in one go and you have this result, you can go one by one. Replace n equal to 1 and find A1. Put n equal to 2, find A2. Put n equal to 3 and find A3 by your calculator. And then instead of writing this one as a total sum like this one, you can do it one by one. A0 plus A1 plus times cosine n 2 by t plus A2 cosine 3 by t, etc. Now, let's start our lecture for today, or the main title of the lecture, how to complete the function of the half range. What does it mean, half range? It means he will not give me the total period. He will give me half of the period. Okay? Let's go for this one. In this figure, you have a function defined from 0 to pi, right? Okay? So if I would like to have Fourier series which has only cosine, so I have to complete the figure of this function to be even because I need cosine only. If I would like to have Fourier series which has sine only, which they call it Fourier sine, for this function, I have to complete the figure in the other half to be odd. So I extend it like this. If I would like to have the cosine Fourier series, I have to extend it like this just to make it even. Let's go for it. Yes. When I complete the other half of my function like this, so this figure is symmetric with respect to y-axis, so it will be even. So if it is even, the Fourier series has only cosine, and Bn will be 0. This is to complete your function to be periodic. So you will complete the figure in the other half of the period, right? So this is the main function, right? This is a main figure. And this one will be repeated every period, right? So now you notice your Fourier series, it will have only cosine, and Bn will be 0. What about if I would like to complete it to have only sine? I have to complete the other half just to be odd function. How it make it odd function? It should be symmetric with respect to the origin, right? So I have the definition of the function in half of the period, and I have to complete it in the other half to have only sine Fourier series. So I have to make it even odd function. Now I know this is my period now because I complete the other half. So my period from minus pi to pi. So my period will be 2 pi. And this graph will be repeated each 2 pi. So in this case, it will be odd function. Because it is odd function, a naught will be 0, an will be 0, and bn only you need to find it. So your Fourier series will have only sine part. Let's go for this example. Expand your function f of x equal to x from 0 to 2 for x in half range. First, to have a sine series. Section B, to have a cosine series. What does it mean expand? It means I know my function in this half range. So 0 to 2 is my half period, right? So the period will be equal to what? Can you answer me, please? Anyone?
It will be 4.
Excellent. Yes. 4. So once he asking you to expand your function from this value, so it means you expand this one because this is the half range. Okay. Next, for section A, what I'm going to do to have only sine in my Fourier series. Can you answer me, please? I have to make it odd or even.
We'll make it odd.
Excellent. In section B, to have cosine Fourier series only, you have to extend this one to be odd or even.
Even.
Thank you very much. Yes, this is the right way. In section A, as you said, I have only sine series. So an and a naught will be 0. So I have to find only bn. This is the formula for bn. Okay. Because I know the half range. Okay. So I multiply bn by what? By 2. Because I have to integrate from minus L to L, right? Because your function is odd and you multiply by sine, which is odd. Odd times odd, you will have what? Even function, right? So if you have even function, no need to integrate from minus L to L. You integrate from 0 to L and you multiply by 2. Okay. This is the point in the half range. So in the half range, you will not find yourself integrating from minus L to L. You integrate from 0 to half of your period and you multiply this one by 2. Next, how you integrate this one? This is integration by parts. Okay. u dv equal integration of udv equal to uv minus vd integration of vdu, right? Again, if you don't know how to do this one by integration by parts, you can find b1, b2, b3, b4 by using your normal calculator. Okay, so this is the Fourier series of my function, which is defined by in the half range, and I complete it to be sine series, so I complete it to be odd. So it will be odd function, so a naught will be 0 and an will be 0. I find bn. So in the bn, my function expanded to be odd, so bn includes sine, so odd times odd will be even, so the integration from minus L to L will be double or 2 times the integration from 0 to L. Okay. This is the Fourier series. Bn is here, time that sine 2n by t over the period, and the period is 4, so you have 2 by here divided by 4, so you will have 2 down here. Next, note that this is, please don't annotate again, please. What is the point of having this one? Look at this one. If this is the Fourier series of your function f of t, right? If you put t equal to 1, so my function at t equal to 1, my function was f of x equal to x. So if I put x equal to 1, so I will have 1. This one exactly as the same as this Fourier series when I put t equal to 1, okay, or x equal to 1. Okay. So, and when I substitute, I have 1 equal to this one. I multiply by 4 and divide it by, I multiply by 5 by and divided by 4. So pi over 4 will be this one. If you multiply by 4, you will have pi as infinite series, because in general pi is approximate value. Why it is approximate value? Because pi is defined by this series, right? When I multiply by 4. So this is the point of having Fourier series, so I can define the pi, the number pi, right? Which is not rational number. Now, to go for the cosine, as we said in the beginning, we have the half range is 2, so the period is 4. Because I'm going to make this one cosine Fourier series, I will extend it to be even function. Because it is even function, bn will be 0, so I have to find only a naught. The definition of a naught is minus L to L. As I said, because this is even, so I can integrate from 0 to L, and I multiply by 2. So a naught will be 2. An, again, instead of integrating from minus 2 to 2, you can integrate from 0 to 2 and multiply by 2. Okay, so you have 2 over 2, which is 1 here. Okay, so how to integrate this one? Again, this is integration by parts. If you don't know how to integrate it by parts, again, you can take a1, substitute n equal to 1 and find a1 by your calculator. Substitute n equal to 2 and find a2 by your calculator, etc. Therefore, you can write this one as a naught over 2, okay, plus, and instead of this big sum, you can make it 1 by 1. a1 times this one when n equal to 1. a2 times this one when n equal to 2. a3 plus a3 when multiplied by this one when n equal to 3. Again, my function f of 2, because my function is f of x equal to x, so f of 2 will be 2. This function value at x equal to 2 is the same as this Fourier series for my function when x equal to 2. X or t doesn't matter because this is the same symbol for the independent value. So when I substitute t for x equal to 2, so I cancel this 2 with this one of these 2. Okay. Now I have this summation. I have this one I move it to the other side. This 2, I move it to this one. So it will have 1 equal to this value. I multiply by pi square. So I have pi square over 8 equal to this one. Again, multiply by 8. So I have pi square as infinite series, right? This is why pi and pi square are approximate values, because it represents by a series. When you stop in a big number of terms, you will have approximate value. If you stop before this one, you have non-accurate value for pi or pi square. Example number 2. Again, this is my function, f of x equal to 2 from 0 to 2. Okay. And he's telling me now f of x plus 2 equal to x. So he's telling me the period is 2. Okay. And my function is odd function. So if you waste your time, you will find by the end a naught equal to 0. So there is no point to waste your time for calculating something you know already it is 0, because your function is odd function. Because if you replace x by minus x, I will have minus f of x. So please, again, check your function. If it is odd, don't go for an. Okay? This is example. I'm just telling you, don't waste your time if you know your function is odd. So you will have an is 0. So don't waste your time to, you know already your function is odd. So an will be 0. So you find only bn. Inshallah, at 2 o'clock, we'll try to solve some of this one. Okay. You will try some of them, 1 or 2 for each one, and you upload it to the e-learning before 2 o'clock, and we will discuss it at 2 o'clock. If you have any question, please ask.